Okay, let's answer the question on whether the Gini and the entropy are giving us a consistent result. Okay, if we go here, remember the first split, we have a 0 for 1, right? So if we want to calculate the entropy, and then that is 1 divided by 5, and then the log 1 divided by 5, and then 4 divided by 5, log 4 divided by 5. So that is the entropy of the first node. Okay, so that is the entropy for this one. And if we want to do the next one, that is 3 divided by 5 and log 3 divided by 5, and then 2 divided by 5, and then log 2 divided by 5. So that they are the entropy of those two nodes. And after that, we want to do a weighted average. So that is the weighted average of the first split. And we do the same thing, and this is the weighted average for the second split. It seems that no matter we are doing entropy or Gini, and the decision will be the same. So the travel cost, so this is the travel cost cheap will be a better split. And let me highlight you another thing. So for this one, this is a very bad split because we have 2 in one class, 3 in the second class, and 2 in the third class. So this is a very bad split. And on that very bad split, actually we can have an entropy even higher than 1. So remember, for the Gini, it's impossible to have a Gini to be 1 or higher, but in entropy it is possible. Okay, so you may ask, why do we talk about the Gini and entropy? So are they very important? Well, they are both supported in decision tree. So when we build a decision tree model and there is a hyperparameter criterion, we can specify. So by default it is Gini, but it supports both Gini and entropy. Okay, so the next task for you will be, let's use a kyphosis, and let's build a decision tree with Gini first. So with Gini, we build a decision tree and then we make a classification. And the next part, we use the same train and test split, and then we build a decision tree based entropy, and we want to do the same prediction again using the same training set and the testing set, and see if we have the same result. Well, I did that once and I got the same thing. So you are welcome to try that first and then see if you get the same thing too. So I'm gonna encourage you guys to pause the video here, finish the coding, and then resume the video because I'm about to show you my code. Okay, so go ahead and pause the video a little bit. Okay, so well, this is my answer. Well, the only thing we did was I created 2 decision trees, so decision tree 1 and decision tree 2, and then I specified the criterion to be Gini and entropy. Okay, and after that, I'm using the same training test set to train the decision tree 1 and the decision tree 2, and then I make the prediction on the same testing set, so I got the same results. So it's likely that you will get the same results too, because well, usually it doesn't matter too much. If we are using the Gini or entropy, we are going to end up with very similar decision trees or even the same decision trees. Okay, so let's do a very quick wrap up. So we talk about the Gini impurity first, and that is the Gini impurity for the decision tree. It's not the Gini index, which is a economic term. Okay, so in the best case, for the Gini, we will have a 0, and the worst case, we will have a value very close to 1. And then we say there is a cart training algorithm. So on that cart training algorithm, it will try to minimize the weighted average Gini after a split, and then it will try to find the smallest weighted average Gini. So that will be the split for the current node. Okay, and then we also talk about entropy. For the entropy, the best value we can find should be a 0. However, in the worst case, the entropy can have even higher values, higher than 1. And Gini or entropy, or Gini versus entropy, and the answer is it doesn't matter. Usually you just pick the Gini, and then it will for both of the algorithms, they will give you very similar decision trees, if not exactly the same tree. Okay, so that is for today, and I will see you guys tomorrow. Bye.